Hello, and welcome to Saratech's Benefits Using Standard Parts Libraries in the Design Process webinar. My name is Sarah Utsugi, and I'm your host today. This webinar is part of a series we're presenting this year, focusing on ways companies can improve their engineering and product development process. Today, our speaker is Rita Tafla. Rita has been a mechanical engineer at Saratech for the past 2 years. She works with Saratech customers to set up customized standard parts libraries in order to further automate the design and assembly process. Prior to joining Saratech, she graduated from the University of California, Irvine with a bachelor's in biomedical engineering. Now I'll pass the presentation over to Rita.
Hi, my name is Rita Tafla, and I'm your presenter for today. So today we're going to be going over these main points, and the main talking points will be what are standard parts, the hidden costs of standard parts, the benefits of using a standard reuse library. We'll be going over how this is done and how we set up our reuse library. So a standard part is a part or material that conforms to an established industry or U.S. government published specification. The FAA's acceptance of a standard part as an approved part is based on the certification that the part has been designed and produced in accordance with an independently established set of specifications. When we think of standard parts, we most commonly think of parts such as washers, screws, bolts and nuts, and other types of threaded and non-threaded fasteners. So many of these standard parts are most commonly defined by many specs that you've probably used before, such as ASME, SAE, NAS, AIA, ANSI, and MIL specifications. So the issue faced with relying on standard parts is that the engineer is really responsible for building out the part every time it's needed in their design or assembly. So companies run into the underlying issue of engineers having to model out standard parts every time they need one, making the use of these standard parts really inefficient. If there's no established shared space where engineers can pull from these standard parts to be reused by more engineers than just the one who created it for their model or assembly, the company runs into the hidden issue of the same part being modeled out multiple times by multiple engineers within the same company. And this causes a lot of inefficiencies in time and productivity. So the picture shown on our right is a standard double hex bolt. It's a commonly used bolt in many industries. And we often forget the actual amount of detail and dimensioning that goes into modeling out what most would think to be a simple model. But you can imagine the amount of time it must take to repeatedly model out such a standard part as a consequence of not having an established standard reuse library. So a current customer that we've worked with has a database that keeps track of how many times a specific specification has been downloaded within that company to be referenced and to be built out and added to an assembly. So our customer actually mentioned that this exact hex head bolt was a very common standard part and that its spec had been downloaded over 30 times. So I've actually modeled out this exact bolt, and after I'd gone in and added every feature and dimension to this part and made sure that it had followed SAE specifications, it had taken me about an hour to complete. So it made me think that if every engineer at our customer's company had downloaded this exact spec and modeled it out to their assembly, the company would have spent at least 30 hours modeling the same standard part over and over again, which is a lot of time. And if we average out an engineer's hourly salary to $100 an hour, that's a cost of over $3,000 to repeatedly model out a commonly used standard part within a company. So these are sort of the hidden costs that companies are spending, paying their engineers to model out these parts instead of establishing a company-wide standard reuse library. So the benefits of using a standard parts library is that it's financially efficient. So from the example that I just talked about, we can see how financially draining it can be to not have a structured standard library and to keep allowing a company's engineers to repeatedly spend the time to model out standard parts. Again, our most recent customer had spent over $3,000 paying its engineers to spend the time to model out just a single hex head bolt. So for a company that heavily relies on hundreds of different standard parts, you can sort of imagine the hundreds and thousands of dollars that they have spent in the past and will recurrently continue to spend unless they have an established reuse library in place for their engineers to use. So these reuse libraries also save time, so you no longer need to worry about modeling out standard parts. It also ensures that these standard parts were built out following specific credible standards, and it maintains consistency and ensures that all engineers are using the same standard part models, which avoids inconsistencies in situations where engineers are responsible for building out their own standard parts at their own discretion to be used in their assemblies. These reuse libraries can also be stored on either a local shared company server or using a higher level software like Teamcenter. The libraries can be built out in a way that's customizable to a company's needs, so only to include standard parts that are most commonly used with a specific company. And from talking to our customers, I think the number one complaint I hear is that engineers dislike the distraction of having to shift their focus from their actual design or assembly project to model out in these standard parts. So from my experience and how the customers have reacted so far to the introduction of parts libraries to their design process and actually making it available to them, many have become more focused to the actual project at hand. So these standard part libraries can actually be set up in many CAD software such as SolidWorks and PTC, but today we're going to show you how this can be easily done in NX. So the three factors or pieces of data that really make this possible really comes down to the part family spreadsheet, the NX model, and the KRX file. So part families are created within NX models to account for all the needed sizes of a specific part type. So there are many benefits to utilizing part family spreadsheets to drive the NX model. One is that the part family spreadsheet is populated to account for all the needed sizes of a part. So this means that only one part file is needed to account for all sizes of a specific standard part. And the user doesn't have to worry about selecting the correct size standard part for their assembly because they can all be accounted for in a single spreadsheet. So I think this is actually really beneficial, a beneficial feature when building out the standard parts because there are essentially no limits to the number of size variations that can be included for a single standard part. So you can ensure that all your needed size variations can be included. And we can access the part family function in NX under the tools section, under utilities over here. And from here, we can access and upload our part family spreadsheet. So this is an example of a part family spreadsheet. So the columns here going vertically represent the expressions that actually define the dimensions. And each row of data going across here represents a single part number and its corresponding dimensions. So you can see how many different variations of sizes of a specific, in this case, a pan head screw that can be added to a single part family spreadsheet. So in this example, there's 55 different size variations that we can see here on the bottom, 55 rows. So once this part family spreadsheet is completed and populated with all of the needed variations of sizes, it is uploaded to the part family function in your standard part NX model. So we use the expressions defined in the part family spreadsheet as shown in the previous slide, rather than like hard-coded values to dimension the model. And in turn, this actually allows the model to adjust to various sizes based on the row of data that is selected and applied to the model from the part family spreadsheet. So we can actually demonstrate this in this video here. So we have our pen head screw, and we can see all the rows of data that are reflected in our part family spreadsheet. And remember that each row of data corresponds to a specific size in a specification and its corresponding dimensional values. And if we apply those values by selecting a row and clicking the apply values, which is that yellow check mark on the top, we can actually see the NX model take on the dimensions that were selected and applied. So I think this is a really powerful tool because it allows to be able to have a single part file that drives multiple ranges of sizes of a standard part. So just think how much time we can actually save just by being able to select a row of data and applying the values to the model instead of having to build out an entirely new model. So how do we set up our standard parts library? So we're now at a point where we have our part family spreadsheet and our NX model built out for this pan head standard part. So once you find yourself at a point where all of your standard part NX models are built out with the part family spreadsheet, we can actually consolidate all of our parts into an organized folder, which essentially makes up your library of standard parts. So a tip I have for this is to make sure you organize your folder in a way you wish to see it reflected in NX. I think one of the most functional parts about the reuse library management in NX is that once you add your folder as your library in NX, your reuse library will be organized in the same way you have it organized in your local folder. From our experience, we have found that organizing your library folder using subfolders of categories is the most efficient way of doing this, and it makes it a lot easier for engineers to be able to go in and find the parts that they are looking for. So for example, in our Saratech standard library example that we have here on our left, we have included subfolders within the library of various categories of standard parts, such as flange hex heads, nuts, and flathead bolts. And each subfolder contains standard parts defined by different specifications. So using the reuse library management allows you to add your library by simply choosing a directory and selecting Add Library, which is this button up on the top left corner of the dialog box. And you can select your folder that contains your standard parts library. So it's really just as simple as that. So how do we automate this? So the final piece of data needed to make this process fully functional and autonomous is the KRX file. So a KRX file is created for the model, and it allows the model to actually auto-fit into the assembly without having to manually select the correct size. So once you have your library in NX, you can select a part and right-click on it to create each part's KRX file. So the auto matching, which is this section here in the KRX dialog box, it allows you to select the expression that will be used to auto match into the assembly. So in this case of a pan head screw, we selected the major diameter of the part to auto match when a hole is selected in the assembly. So the KRX file will actually scan the part family spreadsheet for the correct major diameter that properly fits into the selected assembly hole. Essentially, the selected auto matching expression is what drives this automation process. So we can actually demo this here in this video. So we have a test block here, and to our left, we have our Saratech standard library shown, and it contains all of our various parts. So if we go and drag our screw and drop it into a 1/4 inch diameter hole, we can see that it actually chooses the correct size screw when selected, and it properly fits into the hole. So we can actually do a cross section of the assembly. So we can show the cross section of the screw in the hole. We can drag it back a little bit, and we can see that the correct size was actually auto match for this hole because we see no interference. So to recap our discussion, we can visualize the overall workflow of the standard parts library creation process. So we can start off by creating our part family spreadsheet and populate it with all the needed size variations of a standard part. We can then move on to create the NX model of the part and dimension it using the expressions defined in the part family spreadsheet. We then move on to tie together the part family spreadsheet and the NX model by inputting the spreadsheet into the part family function of the NX model. And once all of our needed standard parts are built out, we organize our standard parts library folder. And then we link our library folder to NX using reuse library management tool in NX. And then create the KRX file for each part within NX to allow parts to auto fit into the assembly. So we can see that by following these 6 steps, we can essentially avoid the hidden costs of standard parts and save a tremendous amount of time and money that can be really well spent on focusing on bigger and more demanding tasks. So the first step is to assess your company's current standard parts practices. So ask yourself and your colleagues, how as a whole company are you currently handling the use of standard parts? Is your company's current methods practical and efficient? And finally, are standard part libraries a solution that will help your company become more efficient and focused on the actual task at hand? I think by asking these questions, we can assess if establishing a standard parts library is a good fit for your company. And if you find yourself in your company needing support, please reach out to Saratech so that we can help support the setup of your standard parts library. Thanks, everyone.
Thanks so much, Rita. So as an engineering company, hopefully you can see that Saratech is focused on helping our customers realize better products through better product development experiences. So we're here to help you optimize, eliminate redundancies, and create better processes. So if, again, like Rita said, if you need any help solving engineering problems, please reach out to us, whether it's analysis, design, data management, or process improvement. Our team is ready and able to assist. So we work with companies in all major industries, from aerospace to marine and energy too. We do small projects and major implementations. And we can help many companies realize better products by improving their product development experiences. So again, like we said earlier, we're here to help, and we're glad you could all join us today and learn about standard parts libraries. Now we'll enter the Q&A portion of this webinar. So if you have any questions, you can go ahead and enter them now. I also want to mention that if you want to reach out to us, the best way is going to be to email us at info@saratech.com, or you can give us a call at the number on the screen. So it looks like we have a few questions coming in. The first one is, how does the KRX file allow the part to auto fit into an assembly?
So the KRX file has a functionality in which it allows you to choose one of the expressions that you included in your part family spreadsheet. And you can choose one of those expressions to be used in order to auto fit into the assembly. So in the example that I provided in the presentation, for a typical screw, typically you would want the diameter of the screw to fit into a diameter of a hole. So the best way to do that would be to select the major diameter. So it's based off of any expression that you choose.
Okay, great. The next question is, once the KRX file is created, where is it located?
So the KRX file is created within NX, and it's actually automatically stored to wherever your standard library folder is located. So you can see that once you create it in NX, you can open up your local standard library folder, and you will see a KRX file that was created and stored automatically there.
And the final question is, once a standard part library is added to NX, can more parts be added to the library folder? And will these updates be reflected in the NX library?
Yeah, absolutely. So you would, once your library is uploaded to NX, you can still always go ahead and create new standard parts, just as you would, as I showed in the presentation. And you can add those to your local standard parts library folder. And then you can go into NX and just right click on your library and just hit a refresh button, and it'll automatically update and include any new parts that were added.
Great. Well, it looks like that's all the questions we have for today. Thank you everyone for your questions. And again, as a reminder, if you ever have any additional questions, comments, concerns after the webinar, you can always email us at info@saratech.com. Make sure to subscribe to our YouTube channel, follow us on Twitter, Facebook, and LinkedIn to be notified of future events and to gain access to our webinar recordings and training videos. Thank you so much for attending. Thank you, Rita, and have a great day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.